Okay, so I can differentiate sine 2x. I know my little sine becomes cos, becomes minus sine, becomes minus cos circle. So sine 2x becomes cos 2x multiplied by what you get when you differentiate that, so which is 2. So it becomes 2 cos 2x. And I can integrate sine 2x as well, because I just reverse the flow, so sine becomes minus cos, so that becomes minus cos of 2x divided by what you get when you differentiate that, which is 2 plus c, and you might choose to write that as minus a half of cos 2x. I can differentiate sine squared x, so I just write it as sine x squared, so I differentiate it like a bracket. So dy by dx, I multiply by the power, reduce the power by 1, so it just becomes sine x, and then I multiply by what you get when you differentiate the bracket, which is cos x, which is sine 2x, by coincidence. I can't integrate sine squared x in the same straightforward way. You can't write it as sine x squared and increase the power divided by the new power, because if you remember, you can only integrate brackets when the bracket contains something linear, so 3x plus 1 to the power of 5 or something like that. So I can't integrate that. But fortunately, my good old friends, the double angle formula, and in particular the cos 2x formula, has a version which includes a sine squared x. So if I take that version there, cos 2x is 1 minus 2 sine squared x, and rearrange it, so I get sine squared x in terms of cos 2x. Now I can integrate sine 2x, I can also integrate cos 2x. So let's plug that into our original question. I'm going to choose to put the half outside, but you know we can leave it inside or outside, doesn't matter. So I've got, and then I can integrate it. 1 becomes x, cos when I integrate becomes sine, so actually it's minus cos, so minus cos becomes minus sine, so that becomes minus sine 2x divided by what you get when you differentiate the bracket, divided by 2, and so that's a half of x minus a quarter of sine 2x. I know I should have perhaps changed my letter, but there we go, that's fine, and you could have written that as sine 2x over 4. So it's worth practicing that for sine squared x, but also for cos squared x. So why don't you pause the video now and try and do the same thing for cos squared. It also uses the cos 2x identity. Okay, pause and have a go. Okay, so so cos squared is what we're integrating. So I went to the cos 2x identity that used cos squared. Remember, we've got all those different ways of writing cos 2x. Rearranged it, plugged it in, integrated it, multiplied by half. That's a half of x. And if you compare that, that's cos squared x with what we did a moment ago, sine squared x, they're pretty similar, aren't they? And that's because they both use the cos 2x identity, which when you integrate becomes sine 2x over 2. Okay?